Hello, everybody, and welcome to another show of the V-Door Locksmith, where we're unlocking the secrets to success in the oil and gas industry. We've got an amazing show lined up for you guys today. We're trying it once again. We are going to try to broadcast live not only on LinkedIn, but on Facebook and on YouTube. So wherever you guys are watching from, we appreciate it. Please comment and let us know where you're watching from and who you're working for, so we can give you guys a little bit of shout out and a slight promotion to anybody. Speaking of which, I do need to do a better job of promoting my own company, who actually does sponsor this show and pay for it and do all the stuff. So thank you to Gibson Reports, gibsonreports.com, your directional drilling market share, as well as a huge thanks to my mom. Yes, I said it, my mom, who is a 30-year professional videographer, who is the person behind the camera and behind the computer, who is making all of these things possible for us today. So Red Flyer Media, and thank you, Mom. And if you're looking for her on LinkedIn, it's Rebecca Cunningham, just so that there's no confusion there. Thanks, everybody, for tuning in yesterday. We had John DeWart on here, and we were talking about the drilling, DSAT is what it's called. I can't remember all the alphabet soup acronyms for everybody. But we do have a great show today. I've got one of my, I would say, a dear friend in the industry, as well as a huge influence and mentor to me, even whether he knows it or not. From Kinetic Upstream, Jeff Lasater. John was the guy yesterday. Jeff Lasater, thank you so much for being here. I really do appreciate it.
It's good to be here, David. Thanks.
Was it a good drive coming in today?
It was awesome. It was awesome. I get to shed. I spent an hour and a half, 2 hours, whatever, shedding Houston, Texas off of me, and it's really lovely here. So it's good to be out here.
Shedding the World Series.
Yeah, we won't talk about that.
Okay.
We still love them though. The Astros are, they're awesome.
One of the things I always do is after my team gets eliminated from being in playoffs or eliminated from the playoffs, I always wear their shirt or jersey or some kind of team paraphernalia the next day.
Right.
So it's like, I'm still a true fan. I still believe in them.
For me, it was socks. I wore the socks, so it wasn't too overstated.
I actually did see. I saw a lot of people who, even here in the Wimberley area, who were supporting the Astros. So. Anyways, so today, guys, like I said, if you guys are watching out there, feel free to fire off any questions that you guys have. I know a lot of people that typically watch the show are in the Upstream drilling, directional drilling, MWD segment. Jeff is by far one of the premier engineers and one of the smartest guys, I believe, in this portion of the industry. So any questions you have, this is definitely a guy to ask. So for those that don't know, Jeff and I actually met working at Tercel. I made a really poor occupational choice for a short period of time, but it at least led to the opportunity to be able to work together. So that was awesome. So for those who don't know your background, which is a very interesting background, I know it's kind of a cliche thing to do during an interview, but give us a little bit of your background. How did you end up in the oil and gas business? What shaped your career? Collegiate. I know there's a lot to that, but you've got a really interesting story. So I'd love to be able to have you share that with everybody else.
Okay, so I was born a son of a football coach, and that's all I'll say about that. But when I was a kid, I was captured by Apollo and the space program, and so all my life I figured I want to be an astronaut. I want to do something with space. All I cared about was working at NASA. If I could work at NASA, it'd be just fine. I saw the movie, the Don Knotts movie, Reluctant Astronaut, as a kid, and I thought even if I swept the floors at NASA, that'd be fine for me. So anyway, I found out about this when I was in high school, found out about this degree called aerospace engineering, and thought, well, I'll have some of that, I'll do that. I could do the math, I was okay with that, but I really didn't know what engineering was. I just knew that I was kind of creative. I loved to draw. I loved to design things, and that's sort of how I went down that path. There was another important influence, and this is a little bit of foreshadowing, but my father was a football coach at TCU, And one of the big supporters at TCU was Marvin Gearhart, the Marvin Gearhart, right? And Marvin, for those of you that know Marvin, he loved to fly his plane, and he loved to fly my dad around the United States to go recruiting football players. And when I was a little kid, I would sometimes on Friday Night Lights, right? I would get on that airplane with my dad and Marvin Gearhart, and we would fly and go see a football game. Little did I know that that would influence my desire to want to fly and to want to go to space, and also sort of plant a seed for Marvin to call on me one day to go help him with one of his investments. So I went to work for NASA, actually worked in the manned spaceflight program for a commercial space company called Space Industries Incorporated. I was fortunate enough to work for some pioneers in the Mercury, Gemini, Apollo space days, and those guys had left NASA and started a privately financed space company, this is what I would call private space 1.0, whereas Elon Musk is doing maybe 2.0.
Yeah.
But a good idea before its time. We've talked about this. A good idea before its time is a bad idea. Yeah.
So if anybody ever hears me say that, this is exactly the guy I got.
And it's not my phrase. It's a guy I worked for, a brilliant engineer, and used to be the head of engineering for NASA, and it was a guy named Max Faget. That was actually his phrase. So I stole it from Max. So I worked for in the human space program for about 10, 15 years, and then in 1997 I got a phone call from Marvin Gearhart out of the blue. And the funny thing was I was about 32 years old, but I'd known Marvin for 25 years at that point. So Marvin calls me, and those of you that know Marvin, Jeffrey, yes sir. I got these guys that I put some money into, and they got this idea, and it's a new drilling thing, and I want to keep it out of the oil business, and you're working in the space business. I figured you might have some guys that could work on this. That's it, out of the blue, And so I met a guy who he had invested in, a guy named Steve McLaughlin, directional driller from the UK, and within about 2 beers and 30 minutes, I think, Steve and I were challenging each other on lines from Monty Python's Holy Grail, So we hit it off. Right away, and so we spent the next. I ended up leaving the space business, and we spent the next 7 or 8 years designing, building, commercializing that technology.
And what was that? That
was called RST. The name of the company was RST, Rotary Steerable Tools. This was again 97, so it was about the same time that Schlumberger was buying Camco. I think they bought Camco in 98 and got the Power Drive. That's where Power Drive originally came from. AutoTrack was still in Germany, actually in Italy at the time. Being tested, and I can't take credit for being the first rotary steerable. Obviously, that was CDA, which is now the gyro data tool, I guess. Those guys, man, they were doing that back in the 80s, like in the mid to late 80s. So we were fortunate enough to get ExxonMobil interested, and about 99, I think. July 99, we got our first run off the coast of California. So that's sort of how I got.
And that was the first test,
business.
the first rotary steerable test in North America?
That was the first rotary steerable test in North America. It would have been Baker Hughes, but Exxon didn't want to pay the mobilization fee to Baker to get the tools from Germany all the way to California at the time. So I think they came in and followed us right behind us. But
Californians just don't understand how representative they are in the oil and gas.
That's right. No, it's a huge deal. We didn't understand that we were going for our first well. I mean, we had been to Catoosa for like 3 days, maybe, because we could only afford 3 days. We couldn't even afford MWD. We were running single shots to see if we were turning the well left or right, which we did. But in the 99 well, we had no idea that when we got on site that it was a world record well, and so all eyes were on this particular well. And the deal was, they were extended 20,000 feet at the time. That was 22,000 feet, something like that. That was a world record. And they were going right, as usual. The well was walking right. They were going to miss the target, and so they needed something. Their only alternative was to try one of these new. They couldn't slide anymore, so to try one of these new fangled rotary steerable tools, and we just happened to be in there, standing on the side of the road at the time.
Happened to be in somebody's Rolodex.
Yeah, that's right. Now, I mean, we were talking to the guys. I mean, my partner now, George Sutherland, was also part of that core team back then, and George,
knows everybody.
knows everybody,
Yeah.
and started hitting the bushes, pretty early with that technology. So we had, a few guys queued up, ready to go. But yeah, it was the first run. I mean, at the time, rotary. Your reaction typically was, rotary what? Not in my well. That was the answer. Not in my well.
Yeah.
That's changed a little bit now.
Yeah, the market's a little bit come around just a little bit. But before we get too far into that,
okay, sorry.
So you guys ended up what ended up coming of that company?
So we divested to Halliburton. They bought us in 2005. And the idea was they already had the GeoPilot. Right, so the idea was that they were looking for a low-cost alternative. They wanted to beat other folks to the market to get, it was a race to the bottom, pretty much, low cost.
And that race is still on today.
And that race is still on, yeah. Okay. So, they bought us in 2005, and we renamed it. That little-known fact, that tool was actually called the Smart Sleeve tool at the time for RST. And it was rebranded as the Easy Pilot tool, and so they had some success with that. Mostly, most people in the U.S. don't have much experience with that tool because it was primarily run in China and Russia, and so it got some experience there. But the problem with that tool it was severely limited. It had a fixed offset, so it was always steering. So in order to go straight ahead, you had to continually move the tool face. And it was battery powered. So for, long tangent sections, we were just continually moving the head and burning power. And so it had some limitations.
So one of the interesting stories I remember you telling me about, as far as being an engineer coming from aerospace into oil and gas, was somebody had told you need to make those bolts bigger.
Oh, God. Yeah. The analysis says it'll be okay, right? What I didn't realize, we had some screws on the first version of that tool. It really did look like a missile. I mean, and designed by a space nerd, it would, and we had holes drilled in frustrums of cones that were, I mean, it really did look like a missile, and there are some tools out there today that look that way too. We've gone for the clean line on our tools now. But it had, I don't know how many, like number 10 screws or number 8 screws or something, which are really tiny. And theoretically, the analysis said that it's no problem, that'll work. But when the roughnecks started torquing screws, we realized real fast that heads were popping off and things were getting rounded out, and it just wasn't oil field. So I think the smallest bolt we agreed using on the outside of the tool was a 3/8 or a 1/2 inch bolt. Sorry, I don't mean to nerd out, with bolt sizes or whatever. Also, there was another thing. I mean, there were all kinds of, what do you say, culture clashes or whatever with the aerospace and oil. I mean, we used all fine thread fasteners, which if you ever tried to start a fine thread fastener, it's like, you can't get it started. You got to back it out a couple of times and put it in. So no more fine threads, only coarse threads for the oil field. Yeah.
So after you guys sold, then you were with Halliburton for a little bit, and then went back to aerospace.
Yeah, I spent 2 years at Halliburton, and how would I describe that? I really did. The people were great, right? The engineers were absolutely brilliant, and they had lots of resources. It just moved, I guess, a little slow for me. So I was, the other thing that was happening is that the U.S. was planning to go back to the moon and to Mars, the Constellation program. And I thought, man, I'm not going to miss this. I had always thought I had missed it by 30 years. I mean, I worked with all these old guys, right? These old timers at Space Industries that were Mercury, Gemini, Apollo. I mean, the original Space Task Group. Yeah. Before it was NASA, before it was NACA. Those guys had some stories, man. Those guys, they really did it. So I thought maybe I had missed it by 30 years. And now we were going back to the moon. And I thought, I'm not going to miss this one. So I left. I went to work for, fortuitously, went to work for a company called Oceaneering, which you may have heard of. They also have a space division, and they're very deeply seeded into the manned spaceflight program down in Houston. They build a lot of EVA, which are spacewalking tools and spacesuits and some really cool hardware. And I got in with those guys, and fortunate enough, they're also in the oil business. So, there were guys that I could speak both languages at Oceaneering. After a couple of years there, all excited about going back to the moon, we actually won a $1 billion spacesuit contract while I was there too. I mean, it was a big deal. But soon after that,
so you got into fashion then.
That's right. Yeah. There's some really, there's soft goods engineers, at Oceaneering that design and build these suits. It's pretty amazing. They just happen to be, radiation tolerant and pressure tolerant and really expensive. But after a couple of years of being there, Congress canceled that program.
Yeah.
Yeah. And so I found myself doing more business development and lobbying, and it was an interesting experience. But a couple of years after that, I got a phone call and said, "We want you to design a new rotary steerable, a next generation rotary steerable." And that was some of the same guys that had invested and that had been with us at Rotary Steerable, and they twisted my arm. After, I guess my first question was, why? Why on earth would you want to do that?
Why would you want to do that again?
That's really painful. You remember that, right? That was really painful. And they wanted a low cost, design for a new market. And and my second question was, surely somebody else has done this. Surely somebody else has cracked the nut on it. And, there had been some progress, but not really. We were still operating and still based on tools that were designed for a more expensive offshore
marketplace.
Yeah.
So then once you got back in, I know that's about the time that we met when working at, I guess we don't need to say it. Well, they don't even exist anymore, but.
Yeah, that was at Tercel.
Yeah, so we were working at Tercel together. Right. Mm-hmm. And at the time, it was called the steering while rotating.
That's right. Yeah. Yeah. Okay. So it's a good story. I was doing some other work while at Tercel for ExxonMobil, some we were doing some design work for some special applications for them, and great guys there. And
all but one.
All but one. Okay. So when I walked in, I remember walking into a meeting. It wasn't even related to rotary steering. We had not gone public with what we were doing. In fact, we never went public with it.
Yeah.
While at Tercel. And so I walked in to the Exxon offices, and there was an individual sitting at the table who said, he looked up and he remembered me from the old, RST days, and he said, "Lasater, you're not in here to sell me another blankety blank, low cost, blankety blank rotary steerable, are you?" And the whole point behind that was that he had been, told by a lot of other companies since then that and the promises of a low cost rotary steerable, they just didn't pan out. And so I said, "No, I'm not here to sell you a rotary steerable. I'm here to talk about a steering while rotating tool." And so we sort of coined it, or it was our secret password, our secret name for that development was steering while rotating. And it's stuck. I mean, we still, on a lot of our documentation, it's called the SWR tool. And it's sort of like measurement while drilling, steering while rotating. So that's where that came to be, and it's now called the contour tool. But anyway, that was it still is. People still refer to the tool as the SWR.
So tell me a little bit about, obviously there was some changes in ownership of the technology and stuff, but we'll kind of skip over some of that because I know.
I don't mind. I don't mind. So the company was bought, and the books were just not right at the time for a company to take on, what was probably perceived as a very deep rotary steerable development well. I mean, you could sink a lot of money, and a lot of people have, right? So without further ado, that program, after a few years of market analysis, I mean, we met with 20, 30 different directional operators, did market surveys. Some of you guys may remember that. We came around asking you about, what kind of tools you wanted, what was good, what worked, what didn't, and specifically what came out of that was a gap analysis for the low-cost rotary steerable. Yeah, so we, it just didn't make sense for that company's business plan, the company that bought Tercel. It didn't make sense for their business plan to move forward with it. So we negotiated a buyout of that intellectual property and started Kinetic. So that was it. That was 2016, August of 2016. And since then, it took us about a year and a half to find the right financial partner. We operated out of a friend's office, Manuel Delgado, one of my good friends, who has a marketing company, had a marketing company at the time. We had some free office space, so he let us office there. And took us about a year and a half to really find the right investor. But we had some very important and vital angel investors and early seed capital that came in. And then after nearly, going personally broke, the whole, entrepreneur thing, right?
Yes.
We landed our investor that we have now today, which is SCF, they're great guys, right? Really good. So once we got that underway, that was about 18 months ago, and last month we put it in the hole for the first time. So we're very new, very just out of the gates.
So how do you feel right now, having achieved getting the tool down hole? Going back from, what was it, probably 2013 when we were working together back at Tercel, or 2012, somewhere in there,
right?
To where the tool's at now,
really nervous. No, that I was, Catoosa took on a whole new meaning for me. We had, with the other rotary steerables, we had been to Catoosa many, many times. But that was, we were going every few months or so, and it was incremental work. This was, we had been working on this for a long time, and so it was pretty key. So I think the success of that, we were all very nervous. We were, you finally got to get off the pot. You got to do it. You got to get out of the shop, even though it's not perfect. That's one of our mantras. Is you got to build quick and test early. And iterate a lot. And so that's what we've done, and we kind of hit one out of the park.
So what was the success, or what were the results of doing the test at Catoosa? I saw a LinkedIn post about it, but I'd rather be able to hear it.
Okay, all right. Well, we drilled a vertical. It was our second run. The first run, we had some questions about a sensor. It turns out that it wasn't a problem, but we had some questions about a sensor, so we ran down a little ways and we came back out. We switched tools. By the way, our tools we named Buzz and Neil and Buzz. Serial number 1 is Neil. Serial number 2 is Buzz. And we gave Buzz a great chance, right? We sent him down first, and we all got nervous about Buzz, so we brought him back out and ran back in with Neil. So Neil got to land on the moon, the second run, we drilled vertically. We kicked off, and we drilled the curve section, and then we ran lateral. So we did the vertical, curve, and lateral all in one run over a period of about 3 days or so. Which the 3 days were, you've got to. We didn't pay for 24-hour service there, so I think we operated 12 hours a day or something. 14 hours a day or something. That's like that. And pull back to the shoe. Yeah.
Catoosa can be a little costly.
Yeah, it can. But I think the other side of it is it gives you time to review data. It gives you time to think about what you're doing. Are you making the right decisions?
Have dinner, take a nap.
Oh yeah. It's a big deal when you're testing for the first time. But we pretty much blew and went. We drilled that section in one run, and then pulled out and put a motor on top, because that's kind of what we do these days, believe it or not, rotary steerables with motors on it. And so we put a motor on and drilled like a bat out of hell, another part of that, another lateral section, and broke an all-time Catoosa record for ROP.
Oh wow!
Yeah, didn't know it at the time, but so we had really good runs, and now we're, according to our plan, right? We're doing all of the last couple of months or so. We've spent time doing the forensics on those tools to look at wear and make them easier to operate and easier to service and maintain. And we're talking with customers now about doing some trial runs.
Awesome.
That's where we are. Yeah.
Well, I know we've got a handful of people watching here, and so we've got some people watching in. So for Sal from Ukraine, so Patty Murphy says, "'Tis only a flesh wound." He's watching from Katy, Texas.
None shall pass.
Yeah. I'd like to know more about your tool. I've run Power Drive, Orbit, Exceed, Weatherford, Halliburton's GeoPilot. Then the follow-up question I think there is, does the tool have a hold vertical mode like Power V? What is the dogleg capability for the build and turn? Does it have a hold inclination azimuth mode for the lateral? So a lot of questions there.
Mm-hmm. Yes. Yes, now and in the future. So what we have. Let me back up a little bit.
Yeah.
And
this is your show.
So the tool that when we decided, when they convinced me finally, I think, to do this again. The thing that sealed it for me, we did the market analysis. First and foremost, engineers, management, research and development guys out there, right? Get the market right first. It'll serve you well, right? Make sure you know the customer, make sure you know the market, and not just where the market is today, but where the market's going. Try to guess, estimate, and then be agile, and that's really what we've tried to do from the beginning. So we studied the market. We saw two things, really, two major changes. Number one was in the profile of the directional driller, right? Now the directional driller was getting younger, maybe with less experience and more digitally savvy, I guess you would say. During my interviews, doing the market analysis, I actually met my first directional driller who had never run a motor. It was only rotary steering. So that's one thing that we noticed had changed, and we needed to make sure that we tailored a product to where the market was going with the directional drillers. The other thing we noticed was that the market had changed completely. I mean, this was 2014, 13, 14, and everything. Of course, it was before
the market changed
the market
again.
Changed again, yeah. But really, the focus was on unconventional U.S. land, hot hole, high dog leg, really tough drilling, and so we knew that the technology had to meet that. It had to stand up to that, and so we wrote this based on our market analysis. We wrote this ridiculous specification. You may have seen it when you were at Tercel, but it was nuts. And so that spec included things like no limitations on flow, very little, basically a through bore, no limitations on rotation or stick slip, high dog leg up to 20 degrees 100, and you and I both know a directional driller that advised it should be 25 degrees 100, and I got him to back off to 20 degrees 100. So that spec had 20 degrees 100. Can we get that today? We could in a perfect well. So with no washout, we've got enough offset and dog leg. The geometry is right to do that. And we've seen indications of that capability at Catoosa as well. So we think we got the BHA analysis right there. But it's a tremendous turning capability.
Wow.
Yeah, and so a lot of people might fall out of their chairs when they say rotary steerable, it can do 20 degrees 100. Oh my God, we never want to do that. Well, one of the other requirements of that tool was that we had a stable housing. We had something that we could measure off of, something that we wouldn't have to spend $100 million figuring out a control system, to be able to move things simultaneously in the right position and counter rotate. We just didn't have the money to do that. In fact, we started with a $5 million budget. We had to develop this thing for $5 million, and a lot of people said couldn't be done. Pretty close. We're pretty close to that.
Wow.
So anyway, so we knew it needed to have a stable housing, which meant that we were probably going to go with a non-rotating or slow rotating housing with a shaft through the middle. We knew that in order to make it have to consume very little energy, to make it more efficient, that it really should use mud lubricated bearings. And we knew that it needed to be fully proportional. It needed to have a variable dog leg, and not just 20 degrees 100. We couldn't, that's crazy, right? So we had to be able to vary that dog leg, set that dog leg to anywhere between 0 and that amount. And so that's what we did. So we have a tool that has, and if you imagine it's got an outer housing that is basically like a stabilizer. The blades are fixed. The contact points provide just a reference point, a centralization of the tool. And then all of the offset mechanism occurs inside, the deflection mechanism occurs inside the tool. And we're able to change that, the direction, the tool face, the way the tool is pointed, independently of changing the offset or the amount of dog leg that creates. So if you imagine it, we can pull the dog leg back to zero and tool face doesn't mean anything. Actually, when we do that, the control system shuts off because it's just like a non-rotating stabilizer. Do you imagine it?
Yeah.
So that's no flow limitations. It's got if you imagine, it has, you were saying that you had a hard time putting that into your database because there wasn't an option for infinity, I guess.
Yeah.
But imagine a 2-inch through bore all the way through the tool, and that's essentially what we have, unobstructed. We don't use mud. There's no pressure drop. We don't use the mud pressure. The variance in flow doesn't change the amount of force that we have. It's a fully battery powered steering mechanism. In order to make that work, again, you've got to have very low friction between the shaft and the outer housing. There's a bunch of things you have to do. You have to build the BHA
so you're
right.
Saying it's not simple.
It is rocket science, yeah. Yeah, it's really freaking hard, you know, and that's why rotary steering is such a difficult thing, a nut to crack. It's not. It's really not. As long as you have an awareness that you have to jump between the micro and the macro every day. And what I mean by that is you can get the mechanisms right. You can get the steering mechanisms right. You can get the software and the electronics and all of that stuff to work perfectly. And you can miss the big picture, like the BHA. You can completely miss that. And so you end up with a tool that maybe the BHA is passing on too much vibration, or maybe it's creating, you know, large biases that are pushing the tool in another direction. And there have been a lot of failures just because of that. So we knew we had to crack that nut, and we have to get that right.
So a very holistic holistic look as far as the whole bottom hole assembly to be able to do the design.
Yeah, and I actually will credit my superior at Tercel, actually, of giving me the leeway to clean the slate. Right? He said he wanted me to, and I called it tabula rasa, which was a game that I learned about a long time ago, but it means clean slate, right? And so we use that phrase a lot in the company. Let's clean the table, let's clean the slate, and let's start from basic principles. And fortunately, we've got the people, we've been able to attract and find those people that can start with those first principles.
You guys do have a good team over there. Met a couple of them.
We do, yeah.
Y'all's front desk person. Top notch.
Right. Yeah. So we really. I've been very fortunate to have the team that we have, and it's not just the individuals that are. I mean, we got, you know, probably best designer I know. You know, I mean, best designer I've ever met. You know, working on the tool, and the best DD. The guy that has the most experience with, you know, rotary steerables in all different worlds, I would say, you know. But I'm really happy, and it's not just those guys, right? We've also, because we're a small company, we've also chosen to go with experts, which are other companies, right, to help us with our seals and our bearings and our communication system, and all the other elements of the tool. Why would we want to become experts on seals? You know, why would we want to become experts on communication system, which we've had to do anyway? But.
Yeah. So let me shift gears a little bit with you and ask you about, so like, obviously you having gone through this design process now twice with a rotary steerable tool and a steering while rotating tool. Why is it that, you know, I continually hear about, you know, people like, oh, I've got a rotary steerable tool design, or I've got an RSS design, or hey, I've got the new one. Why has it been so difficult for people to really be able to master this? What do you think has been, obviously, I mean, you guys have looked at this, but what do you think like the majority of other people have missed out on, that have kind of almost like poisoned the well per se, as far as people doing this?
Oh, tell me about it. We spent 1.5 years trying to raise money. There were a lot of dead bodies along that path, and a lot of investors, I think, that had been sort of taken to the bank or burned on some of that. And I don't know, Dave. I mean, it's kind of a complicated problem, right? It's not just all I need to do is get the geometry right, and the rest will work itself out. It's got to be rugged. It's got to be reliable. It has to have, we call it radial real estate, right? Radial real estate is king downhole, because you take the hole, right? And I've got to have something that contacts the borehole. I've got to have some structure there, and then I've got to have something that spins the bit, and then I've got to have all this stuff in between that makes it move, and that has smarts and electronics to make it do its job. So it's a packaging nightmare. We were actually able to package one of the, a lot of tools have to be taken apart completely to change electronics and batteries and all of that stuff. In 10 minutes you can change the electronics and the batteries in this tool. And we did it that way because we had, we were going to sell this tool initially, and we had to make it fully field serviceable. So that's the other thing about this tool, is it's fully field service. You can service it in a motor shop. Change out batteries, change electronics, change bearings. Just need a breakout machine, and you can do so. So what? But I went back into the pitch for our tool. Why do I think other guys have maybe failed? Well, I know there are a couple of instances where a tool started out as a really good design, but maybe very complicated. Yeah. And all they needed was about 8 years of consistency, to make that tool work. Sorry, that sounds, it doesn't sound so easy, and it's not. But what happens?
Well, I mean, this has been a long road for you guys as well.
It has, yeah. But what happens is, you get a guy that's a good inventor, and he invents a tool or concept, and then he passes it along to the next guy, and that guy maybe gets it to testing and designs it and develops it, but then when it really comes to commercializing it, he's going to pass it to somebody else. And so there's no real bloodline. A lot of these tools suffer that. They've been in the business for a lot of years. I mean, some of them as long as 20 years, and they still haven't quite sorted out, making it truly commercial. And when you lose the bloodline, it's really difficult. And I've talked to some good friends of mine that have gone the way of the dodo, I guess you would say, in the rotary steerable business, and they've told me that the problems were that the guys in charge of it now don't have the wherewithal. No, that's not fair. They don't know enough about the tool and the history of the tool to make changes, to make the kind of brutal changes that need to be made. So that's that's a difficult thing. You got to have some consistency to get it to full commerciality with the same team. I think that's a big deal. The other thing is, if I look back at RST, I mean, we were one of the few that actually made it out of the muck, that got acquired, and actually had some momentum with that tool for a number of years. We had one thing that was unique about RST, and maybe not unique about small companies, but definitely some of the bigger companies, is we had engineers going to lunch with shop technicians, going to lunch with marketing people, going to lunch with the executives of the company, going to work with operations guys. Everybody was a team. And so if you send a tool to the field, if you were an engineer and you sent a tool to the field and the directional driller had a problem with it, he told you directly. And he told you in so many words exactly what failed and why it failed and how embarrassing it was when it failed. That's important, right? That's part of, it's very similar to Kelly Johnson Skunk Works. He had guys that were working, the guys that were flying the planes were the same, were on the same team with the guys that were designing it, and everybody was taking responsibility. Individual engineers had responsibility, and it's stressful. For a lot of engineers, they hate it. They don't like that.
Most engineers are introverts and would much rather just stay behind the computer draft board or whatever.
There's some truth to that, but I think there's a whole bunch of them out there that really want to be hands-on. They want to be in the middle of it. They want to get out and see it operate. And it surprises me. We still bring in guys that are middle-aged guys that have been designing tools for years, and they've never been to the rig. So we put, it's true. And the aha moment is great, right? When you take them out to a rig and they look at it and they go, oh, that's why you were telling me to make that twice as thick. There's a bit of a shock, going to a rig the first time and seeing exactly how things operate. So one of the success, get back to RST, one of the things I think that was successful is that we were made up. Half of us were operations guys, and it's actually over half of us were operational folks, and the other small portion was engineering. So you had a very strong will and influence of the operational side. So we had to make it, user friendly, and we had to make it work.
So obviously
not
there's
just in theory.
A good feedback loop for the communication side. And how things were working there.
That's right. Yeah. So, along the same lines on the feedback, what we didn't really realize in the early days. I'm changing courses a little bit here, but what we didn't realize early on was the importance of. We knew that rotary steering was would you say, was a necessary technology to get beyond a certain length in extended reach wells. We knew that we had to start rotating the drill string so that we could still steer. What we didn't really realize was the importance of having a platform now at bit, right at the bottom of the hole, with smart electronics, with a control system, with a whole bunch of stuff, right, that we could use, a feedback control system right on top of the bit. And that's one of the things that we realized early on in our tool, in the Kinetic tool, was that we really needed to put more processing power than we could imagine at this point. So we did that. We have a processor in the tool right now that's doing absolutely nothing. It's our automation. It's our automation processor, right? And so that software is in works, right? It's going on right now.
Yeah.
But we're still running in manual mode. But we realized that automation was going to be really the way of the future for steering. And when I say that, what I mean is, one of my first projects that I worked on early in my career was the Mars Pathfinder project. We were consultants for the entry, descent, and landing section of that mission, and we had a little bitty rover on board that could talk all the way back to the Earth. And but the data rate was ridiculously slow, and we had this huge latency in communicating with it. So those
still
guys
faster than MWD tools today.
Oh, way faster, yeah. but the delay wasn't, we had 29-minute turnaround delay, on communications. So that was, pretty difficult to control something. I wasn't one of those guys doing that, but I observed this while we were working on the project and how they were building these autonomous control systems. So they could give it some guidance and tell it we want to go here and there and avoid that and this, and then it could make those real-time decisions, those micro decisions. And essentially that's what we've done with the Contour tool, and that's what we're doing with it. Because that pipeline that is so tiny, right, going down to the tool, and it's so slow, you're screaming if you're 5 bits a second?
Yes.
in short of wired drill pipe, which we're not really putting a bunch of our time and money into. I'm not saying that won't ever take off, but for us and for the market that we're serving, that pipeline down to the tool, that bandwidth, I guess you say, is extremely low. And so we can get just a few bits down. So how on earth could we, get any kind of real-time steering? And so we've decided to put that control system, that feedback loop, right into the tool downhole, so we can give it some guidance and it can sort out the rest. And eventually where this leads to, right now, we're just doing the typical kind of hold, the inclination hold and the azimuth hold. But in the near future, I would say, mid to late 2020, we'll be populating that processor, that automation processor, drilling automation processor, and actually taking us, that will take us to the real coordinate steering where we're putting in coordinates and it's actually tracing that out.
Wow.
Or even geo steering, automated geo steering as well. So we've got those guys on the team and they're working hard on that. It's just going to take some time to get that right, and we have to make some money before we reliably, before we can go do that. And what we did is we have this long range plan, and I don't want to get into the whole details of it, but it's a 10-year plan. We recognize, though, that the first most difficult part of that was to get a reliable, proportionally controlled, low cost rotary steerable, and so that's our first milestone in that process.
I think even just having that, you can dominate the marketplace. Even if you ignore the automation and stuff, like you can do so much in the marketplace just having the low cost
and
reliable tool.
that's true, and we've had a lot of folks jump to that conclusion as well, and that's a good conclusion. I kind of feel like some of the big guys are saying, what you need to do, you just need to worry about the other stuff and don't worry about the stuff we're worrying about. That's okay. I'm not saying that we're going to get it all sorted out and we're going to be as good as those guys, but we've put the hooks in. We've put the hardware together to make it a part of that grand architecture for automated steering.
So then that brings me to another question, which is, how do you see the changing landscape for directional drilling and MWD? Because I don't want to say one and the same, but very similar in there. How do you see that changing landscape going forward? So one of the things I've seen lately is the operators bringing the directional drillers in-house and sort of vertically integrating. Excuse me. Sorry, I felt that coming, and I was trying to it's not going to happen. It's not going to happen.
You can't fight it, Dave.
Yeah. So you see the operators who are vertically integrating and bringing in the directional drillers in-house, which essentially takes away a part of the directional drilling service company's product line, right? So then if you've got MWD personnel, you got DD personnel, you got MWD tools, and you got motors, and you take away the DD personnel, now you're just left with MWD people and equipment and then the motor. So how do you guys, as far as that's concerned with where you guys are at, how do you guys see the industry going forward? And have you guys been privy to any conversations that you think would...
I guess we've been privy to a few conversations, but most of those are under NDA. But
fair enough. But tell me everything you're not supposed to say.
Yeah, can I just tell you a little bit and beat the crap out of you?
Sell it to everybody live on LinkedIn and YouTube and Facebook, which happens to be working. So let us know where you guys are watching from. So I would, first off, the person you probably ought to be asking are the operators. I can't get completely into their heads. I do know that the technology that we're working on it really changes the role of the directional driller. It does. And
Whether it eliminates people or not, I don't know that that's the case. But what it does is it makes the process more predictable and more reliable, and easier to control and easier to meter, because we're saving all the metrics, right, of what we're doing, because it's automated.
Yeah.
I do think that, like I said, the role of the directional driller and the profile of the directional driller is changing. But I don't think that necessarily eliminates that person. There's still got to be a person that's watching what's going on. It's, obviously supervised automation, and is not even there yet, right? It's still manual right now. So again, the people you ought to be asking probably are the operators. I would consider myself a bit of an industry outsider.
So yesterday was the
George, however, is an insider. Maybe you should ask George. Yeah.
All right, George, you're going to be next on the show.
Spill it all, George.
You're not busy enough as is.
Yeah. So I don't. I do think that that I would expect that guys that are making navigational decisions, our intent is to have a tool that's simple enough to service that he could be the same guy that sets that tool up and runs that tool. There's still a need and a requirement for survey quality control. Yeah. We're not quite there, although we do have survey packages both inside the tool and still in the MWD that we're talking to. So we've got multiple survey points along the way as well, which we're going to be using in the future.
It brings up a good thought there, is that the simplicity of the tools to operate would allow for there to be a more multi-dimensional role. So that if steering and doing the navigation side of it was more simple, and MWD tools and survey taking was, a lot of the complexity that's there is just like in the paperwork and putting the tool together, and stuff that really doesn't, that could be designed out, would allow for somebody to be able to say, okay, now I understand. Like the MWD tool is easier to put together and run the surface system, and the rotary steerable tool or the motor itself is easier to run. Now I can, my bandwidth has been opened up. Now I can do both jobs at the same time. Right. So that's a interesting concept to be able to think about, because obviously we're not removing people from, we're not automating. The machine's not taking the place. It's just the machine's doing different portions of the workload that you would have done in the past.
Yeah, I mean,
that was the overarching thing.
I think John gave it a perfect analogy yesterday.
Yeah.
I think it was John who gave the analogy of ABS brakes.
Oh no, that was Mark.
Or is that Mark? Week. That was Mark. Yeah. The
yeah.
Analogy of the ABS brakes. Aren't we all glad that we have anti-lock brakes? Guess what?
Say for sure. Yes.
Guess what? There's a control system behind that that's making decisions about 1,000 times a second to make that happen. And that's all we're talking about, right? We're putting that kind of technology into a tool, and we're completing this downhole feedback loop. It's still controlled by an individual or by the surface. It's just got some micro control things that are happening downhole.
Now with ABS.
That's right.
You just have to.
Hopefully, we don't have to put on the brakes too fast.
You just have to come up with a good acronym for that. Do the automation steering system.
Well,
no, not automation steering system.
Yeah. So if you, I don't know if it's still on our website. Probably is. KineticUpstream.com. I think we called it an automated steering system. So it's the Kinetic Contour Ass, I guess. I've been looking for a better acronym for that. I heard somebody use AS the other day instead of ASS, so I don't know.
Anybody that's watching out there, feel free to
We're having
to Jeff or to the kineticupstream.com website what a good acronym for the tool would be.
Yeah, we're offering a prize. No, we better not say that.
Yeah, we'll offer up a Gibson Reports sticker and coffee mug, which still haven't come in yet. They're supposed to come in today, so we'll have those in the future. So let me ask you this: like, how do you see the market for rotary steerable tools going forward? So there's a lot of people saying that, like, obviously that market's going up, but motors at the same time are getting better, and I think that's right. Motors getting better has also held off some of the rotary steerable development. Do you think it's going to kind of continue on that same market trend as the motors are getting better, the rotary steerable tools are getting better, so like the market share is going to stay the same, or do you think that at some point that crux could take over where RSS tools are doing the lion's share of the work?
Well, you still have a motor in the hull pretty much with a lot of the rotary steering systems, by the way. So you're not completely eliminating.
I should say the steering system. Yeah, the steering system, whether it be the bent housing with a mud motor or steering powered, additional power, not just from the top drive, but also a downhole motor with an RSS.
Yeah, I mean, I'm biased. I'm completely biased.
That's all right. My reports have to be unbiased. Your opinion can be completely biased.
Yeah, I mean, a rugged machine with a really simple feedback loop at the bottom of the wellbore to actually steer it, where the guy at the surface doesn't have to worry about trying to hold the tool face or flow or weight or rotate or slide, or to me, it just seems inherently like a better idea. Somebody, I remember when I was at another company, somebody was promoting the idea of having the equivalent of an agitator, something to vibrate the drill string to reduce the friction. And this was the same time that we were developing a rotary steering system, and I sort of raised my hand in the meeting and said, I got an idea. He said, what? And I said, why don't we rotate the drill string? I said, that does a really good job of breaking the friction. Well, that requires a rotary steerable, and that's too expensive, and but yet so many of the electronics guys, the MWD guys, the agitators, to vibrate the drill string even more than it is now is just inherently it wouldn't be my first choice, I guess. But it also requires a smarter system to be downhole, which is more expensive and drive the costs up. But so what we in order to get the price down, we had to do things differently. There's a lot of guys saying we can get the price down. We have low cost rotary steer, but the problem is they just have looked at the situation from afar and think, yeah, I could probably do it cheaper than that. And it turns out that it's very difficult. So we skinned the cat many different ways. And
no cat.
Sorry, no. Sorry, cat lovers. We sorted that. It looked at that from many different directions, and found that there were we came up with about 10 different reasons, real, credible reasons why rotary steerables were more expensive. We tried to eliminate as many of those as possible. And I mean, fatigue and stress and replacing items, failure in electronics, lack of steering control due to coupling with the BHA, things that weren't even the tool's fault, right? But were things that were not understood. So we tried to eliminate as many of those as possible. Expensive assets that require, if you've got two rigs, if you've got a rig and you've got to have two tools, one tool and a backup on that rig, you've got one in transit, you've got one back at the shop, you've got another one in transit, and so now you've got capital asset, 5 or 6 tools associated with one job. If you can service it at the motor shop down the road, then there's only 2 tools associated with each job.
It makes it
Yeah.
a lot easier.
New question.
Oh, new question. Are you?
Okay.
Okay.
I don't.
Vortex unbent motor with RSS below. How do you communicate such jump data to the MWD?
Okay. I'm not sure what the Vortex reference is, but
Maybe they're answering your question from before or something. I'm not sure.
okay. Yeah, so we have a communication system, and one of the things that is part of our overall architecture is we knew, while I was visiting all of these directional companies, talking to them about what they needed, what their desires were, I'm looking at, by the way, this was the 14-15 time frame, I'm looking at shops full of inventory, like MWD systems out the wazoo. And I'm thinking, I'm going to come in here with my own rotary steerable and my own probably MWD linked with it, and I'm going to say, hey, by the way, lay down your equipment and we're going to run with you.
Take everything. Take all of your physical assets.
That's
out
right.
To pasture.
That's right. No more motors. No more. Yeah, we're going to come in with our own system. And I thought that's going to be impossible to sell. It's going to be very difficult. You got a lot of assets out there that are great tools, right? The MWD systems that are working just fine. And so we decided at that point that we would not try to be the everything, that we would just facilitate the connection with those MWD systems. So we set out designing a universal translator, I guess so to speak, we call DrillCom, which will plug into the MWD systems. Imagine a module that plugs into your MWD, and then that has a radio, which is a short hop in it. So we can communicate. We went out and found what we thought was the best short hop on the market. We did a little partnership with them and developed our own 2-way short hop. I say our own. We buy it from them, but and so we can communicate. We can jump around a motor, and so we would which is good because it means you don't have to put the MWD right above the RSS. You can put the MWD further up the string so it's not getting the vibration and the high rotations from the motor. So yeah, that's how we communicate to the MWD system. And then that, right now we're integrated with an EM, really a dual telemetry system. So we can either communicate back to the surface with EM or with mud pulse. And down to the tool with RPM right now or EM, just depending on what the formations are like.
Yeah. Well, the good thing is that the with EM going, if you're sending it down to the tool, you got plenty of power at surface to really supercharge that signal.
That is true, and what we hear, there's pretty good. There's a better possibility of getting stuff down than there is getting stuff up.
It's reversing the bottleneck.
That's right. That's right.
So somebody said it's a SLB term. Patty said Vortex is an SLB term. PD Vortex, same as motor with RSS. Oh, power drive Vortex. Okay, I see what they're saying. With MEMS gyro, not magnetometer. Okay, so somebody said at some point someone will turn the mud motor into a power inverter and allow for more integrated SLWRD steering while rotary drilling. Steer and log while rotary drill. Yeah, it just comes off the tongue real easy, doesn't it? Obviously, it doesn't work in the marketing department. Nothing against you, Andrew. I'm just saying that's not going to be what anybody puts on brochures there.
Yeah, so tying logging, if he's talking about tying logging to steering, absolutely. So that's if you look on our roadmap, we start with this rotary steering mechanism. We complete the communication loop, which we do now. We basically have a downhole network, so it's a multi-node communication system downhole. We complete that link, then we add in some more technology which is in process right now, which is just software basically that ties two sensor inputs together. So, imagine you have two surveys, and how can you use those two surveys together to make ellipses of uncertainty smaller and such. And so, and then the next step is the coordinate steering, really, where we can send down, give it depth information and the whole information, give it a trajectory, and it'll actually drill that trajectory.
I've been telling people for a long time
Yeah.
that's the way to go.
Yeah.
So
we're
happy to hear that.
well. Yeah, it takes some time. That's not where we're jumping to first. And anyway,
Yeah.
it's in our architecture, and then sort of the final step, right, is tying all of this to the geo side of it as well, and being able to steer to the formations.
Okay. So let me ask you this. So as far as when you're doing the design and development of this tool, having been in the aerospace to oil and gas, back to aerospace, and then back into the industry, was there a point in time like when you guys were during the design and development of this, and you're like, man, if we would have had the electronics this small, if we had this on our original design, it would have gone so much we spent years doing this one thing, but now we can buy it off the shelf and it's this big.
That's right.
What were some of those, like, the comparisons there between the two?
I'm looking in the camera here. Do I have the camera? Yeah. HC11 processor. So any of the electrical engineers out there, they're thinking, oh my God, that's a pretty old processor. I think we had maybe 128K of memory, maybe. Yeah. And so we had to be very compact and concise with our code. All of our motor control, we have little motors that move things. A couple of very expensive, very high performance motors that actually do our actuation used in aircraft. It's like 747s. I mean, these are really expensive stuff. But those motor controllers, right, we had to write on the first version of this, which was way back when, right, we had to write that code in machine language. I mean, there was like a guy whose job it was to write that code for I don't know how long, probably 6 months or so to make that work. Now it's in a chip. The motor controllers is just, it's pretty simple. And my electronics guys are rolling their eyes right now. Yeah, right. It's real simple, Jeff. But it is. But yeah, our processor. I mean, we're using something like the equivalent of of what's in an iPad. I mean, it's nuts. What we can do with that. And we had so much space left that we put another one in. So we have and oh, by the way, it's not doing anything right now, but that's our process. That's our steering processor. That's our automation processor. So we
have room for another garage.
Oh, I'll tell you the other thing. We
have
we have distributed processors all over the tool. It's not just one. We've got the tool has its own bus. We call it K-bus, but it's got its own bus, right, that it communicates on, and.
Which is important because
amazing.
There's MWD tools that are limited just by its ability to communicate within it, on the system or on the string itself. So that's an important thing to take into consideration, is be able to put a communication bus that is highly proficient.
Well, it's already when you have a bus, the big guys know this. All their systems have, I'm sure, their own, very complicated proprietary buses and all. These are data buses, by the way, folks. They have their very complicated communication system internally. We've already come upon situations where we're like, oh, crap, we need to add this capability, and we don't have room in our electronics to do. Well, we'll stick it out here. Well, how can we do that? Because we'll just hang it off the K-bus. Right, and just put it off the bus, and run 2 wires to it, and it'll be fine. So it's pretty cool. It's given us some expandability. We also made sure that when we designed the communication system, we made sure that it was capable of being multi-node. This is the short hop system.
Yeah.
So now we can, in theory, talk with not just with the steering tool and the MWD, but we can talk to LWD tools. We can possibly talk to near bit subs that are, I mean, we're pretty near, right?
Yeah.
But there are near bit subs out there that we could get extra information. Maybe drilling dynamics tools. And our idea is to make that pretty much open source, you know, where we'll provide you the radio, the modem, and you know, we can communicate with you on that.
Interesting enough. Let me know about that, because I was just nominated by Mark Anderson to be the subcommittee chair for the DSAT group Open API Communications chair group thing.
Lucky you.
Yeah, because we were at the meeting and I was like, a lot of these companies, they're saying they have open APIs, but I don't think everybody knows that they do. And he was like, I was like, we should just make a list of those. I'm good at making lists. It's kind of how I made my business.
Right.
And I was like, I could make that list. And so he was like, you have now been voluntold. I was like, oh, great. So yes, please keep me posted on that. And then if anybody out there has got a good software design that you think would work well with a rotary steerable tool, then be on the lookout or start doing the design development now. I think everybody in the field should start taking coding classes, because there's so much open. In the near future, I see, and you may have seen this, is that there's a lot of the drilling contractors, the operators as well, and some other technology providers, kind of like yourself, that are opening up these APIs so that you can put an app into their system and say, yeah, you know, design a geosteering high ROP turn something. You know, it's there, and those possibilities are coming up, if not already there. I don't know anybody who's done something, but I know that there's plenty out there that are doing it.
Yeah, we're trying to stay really as simple as possible. You know, our communication system, it'll talk QBus, and it'll talk, you know, the what's
CAN bus?
Yeah, CAN bus. You know, and there's another one. Of course, it'll do K-bus, but I mean, you know, we're trying to think of it like Kmart, right? We're the cheap tool. But I think that you know, it's pretty, for us. I'm not sure that it requires an API. You know, I'm not sure it requires some open-ended, other than you know, just like the generic variables and the generic controls that we've been passing back and forth for years with MWD systems.
Yeah.
I don't see it as any different than that. We're just using, you know, we're using them as a throughput, as a communication system, and we're taking data from them and we're processing it, you know, however we want to process it.
All right. Well, hey guys, if you guys are out there watching, please like and share the video. Let some other people gain in on the knowledge that we are sharing. And I want to kind of shift on you a little bit. I didn't tell you I was going to do this, but I want to ask, what advice do you have to entrepreneurs who are, I mean, it could be inside oil field or outside oil field services or technology, but obviously you've gone through building a company, selling a company, working for somebody, then taking on the technology yourself, fundraising, getting to this point. What are some of the strong lessons learned that you've gone through that you could impart on other entrepreneurs as they start their journeys?
Don't do it. No. That's not true. You know, I don't know how I get to exist without. First off, you know, determine whether or not you're comfortable with uncertainty. You know, ambiguity, I think, is what they call it. And somebody famous said that. Somebody will look it up and tell me exactly who that was. But you know, the entrepreneurs have to be okay with maybe not having the final answer right now, and maybe not knowing where their next paycheck is going to come from. And that's difficult, right? And some people have the fortunate opportunity to have enough money not to worry about that. Others, like myself, you know, we have to worry about those kinds of things. But as long as you have make sure that not just you have a comfort with that ambiguity, but also your significant other, and your significant others have comfort you know, with not knowing where that next paycheck is
and
going.
co-founders and
Co-founders and
potentially
everything. Yeah.
first line employees.
Yeah. So I would say, you know, that's sort of the first, the number one thing, right? Before you even go off into that world. And we're talking about being an entrepreneur, right? I mean, taking your ideas and running with them. I would say that the other advice I would give is, you got to want to change the world. I mean, you got to be really driven. At least, in product development, which full disclosure, right? I've only done product development startups. So in product development, you've got to have the vision. You've got to be crystal clear with the vision. You've got to make sure everybody's on the same team and on the same wavelength. Partnership, your partner is literally your partner. If you're not comfortable, I see a lot of relationships go sour and south when guys aren't 100% honest with each other. So, you know, if you have a partner, you should be willing to get married to that guy. No, sorry, I don't really mean it that way.
That's legal now.
It's, yeah, but I mean, it's like a marriage.
Yeah.
You know, and when you're having problems, maybe family problems or financial problems, you know, you've got to, if your partner's with somebody in a firm, in a business, you've got to know that. So I would say, I guess the moral of that is choose your partners very carefully and wisely. And then never underestimate the financial part of it, you know, and how difficult it might be to convince somebody to put their hard-earned money into your idea. That I thought it would be easy the second time around. Really thought it would be like falling off. I mean, I guess it would have been easy had we been willing to give away most of the company. But we felt that the valuation was higher than, you know, what a lot of folks did. And then, you know, make sure you have a really good sound plan. You know, a great idea. There are lots of great ideas. I mean, seriously, not just saying that. There are a lot of great ideas, but having a plan to execute that idea is important, and that involves not just technology, but how it operates, what the user experience is, how you're going to market it, how you're going to fund it and sell it, and when you're going to start making money. Because that's...
How do you define going commercial?
You know the answer to that. So we had somebody ask us that question not long ago, and I can't take credit for this. George Sutherland, you know, he stopped and thought about it, and he said, you know, for us, we consider ourselves commercial when we do a job and somebody pays us for it. So that's commercial. Obviously, you know, we've got other goals, mean time between failure and number of runs and all, but yeah, that's it. When we do a job and we get paid for it.
Sorry to interrupt. So you're saying, you know, making money as a company, knowing how to do each one of those things.
Yeah, or knowing how to find the right people to do it and the people that you can trust. That's the other thing. You know, in a company, trust is, God, it's everything, especially in a small company at a very early stage. I got a tidbit of wisdom, soundbite, I guess you would say, from one of the founders of Space Industries, the commercial space company that I was in. And that was, think of ourselves not as a small company, think of ourselves as a big company at an early stage. And so that's the way we see ourselves, right? So we have to do a lot of planning. We have to think about risk mitigation. I mean, stuff that you just don't want to think about as a small business. But if you do that, if you put the configuration control in place and the document controls and all the safety measures and all the things that you just don't want to think about as a small company, you're going to have to do that because one day that's going to make or break you. Yeah. And it's better to have a system that's already, that you've got some of that stuff in place. I'm not saying that, you know, to overwhelm yourself with bureaucracy. The great thing about a small company is that you can make it up as you go along. If a certain process doesn't make sense, then you go, that doesn't make sense. There's no value added for that.
I love the sound of policies breaking.
Yeah, it's nice, isn't it? You gotta
Yeah.
have a glass, you know, that you break. You got sound effects back there, right?
Yeah. In post.
Yeah.
All right. Well, then, if you guys have any more questions, fire them off. Let us know. So then, I'll kind of ask you here in the end. You know, what do you see as the future for Kinetic Upstream? Like, where do you guys see yourself 5 to 10 years down the road? I know you've got the plan, so
Mm-hmm.
just don't know how much of that you could share.
Yeah, no, I think most of it we can. I mean, we will be a fully. We may have different levels of automation, but we'll be a fully automated steering system. And whether it's steering to points in a 3D space, or whether it's steering to geological parameters, you know, we'll have hundreds of tools out there running, I suspect. I mean, this year, by the end of 2020, we expect to, you know, probably have, I don't know, 8 or 12 tools built, and then, you know, they come in batches of 20 or 30 after that. So,
Wow.
yeah. So it's pretty aggressive. You know, like I said, we've got good financial backers, and we're going to move fast, but not, you know, not so fast that we leave a bunch of carnage behind, and that's the trick. Right, that's the trick right now. So you know, hopefully we can. It's not that we just want to change the industry. We want to make it a little easier, right? If I can relieve some headaches, and make things a little easier to control, or maybe even easier to visualize and control, and I can offer that to the sort of a new paradigm of directional drilling, then I think, you know, we're there to play a role and a part in that.
Awesome. Well, thank you for being on the show today. I appreciate it. We didn't get very many questions, but that's all right. So if you guys want to know more, kineticupstream.com, as well as follow Jeff, link up with him on LinkedIn. George is on LinkedIn as well, George Sutherland. Jim Mock.
Mm-hmm.
Find him. He's a great guy as well, all three of them. I know there's a couple other guys within the group there.
Yeah.
I feel bad if
Gary Althoff heads up our technology, our engineering.
Yeah.
And we've got a whole great core of guys there.
And so if you want to be able to see this tool in person, November 7th, the IADD will be having their annual rotary steerable event, and you'll be able to come out, see the tool, maybe even touch it. If you allow people to touch it, you can get that close.
Maybe, depends on who you are.
But it's Thursday, right? Thursday, it'll
Yeah.
be the IADD RSS forum. You guys can come out and see all of the RSS tools. I will be doing a presentation on the new RSS database. There'll be a lot of tool providers there with their tools. It'll be a great event if you are looking to be able to learn more about what's upcoming, what's available, and what's in the industry. And as always, you know, IADD is a great organization to be a part of. Why I'm one of the board of directors there, so I like it. So, Jeff, thank you so much for being on the show today,
You're
man.
more
I
than
really,
welcome.
really do appreciate you driving all the way out here.
I'm proud of you, man. You're doing great. This
Well,
is
thank
really
you.
cool.
I appreciate that.
It's
I really
nice to
do.
get away from Houston.
You are welcome out here anytime. So, guys, as always, thank you for watching and know your industry.